Hi, welcome to my video on part 2 of the reciprocal ratios. And this video is going to deal with the primary and reciprocal ratios of different angles. And let me explain that. Example. Let's find each. We have a triangle ABC in which AC is perpendicular to BC and the sine of angle A is 3/5. Find the cot of B. Notice these two angles are different. So what I do is I draw a triangle. The triangle is ABC, and where AC is perpendicular to CB, so that means AC is perpendicular to BC. There's a right angle at C. And it says the sine of angle A is 3/5. Well, we know that SOHCAHTOA is sine is opposite over hypotenuse. Cos is C is adjacent over hypotenuse. And tan is T is opposite over adjacent. We can put an equal sign between there if we want, or just leave it. So, but that's the primary trig ratio of an angle. Now sine is, the reciprocal of sine is cosecant, and cosecant is hypotenuse over opposite. And cos is secant, SEC, and that's hypotenuse over adjacent. And tan, reciprocal is cot, so that's adjacent over opposite. So based on that, let's go to work. You have to, when I do trig with these sine, cos, and tan, secant, cosecant, and cot, and all of them, I write this down every time and keep track. So the sine of angle A, sine is opposite over hypotenuse. So here's angle A, opposite is the 3, hypotenuse is opposite the right angle. Hypotenuse is the longest side opposite the right angle. That means that we have to work out the cot, and the cot of angle B. Cot is adjacent over opposite. Cot is the adjacent over the opposite. But that means that I need this other side. So we have C squared equals A squared plus B squared. So we have the hypotenuse, C is the hypotenuse, this is 5. 3 is one side, and the other side, we call it X or B, makes no difference. 25, 9, X squared, or we can call it a B, call it B if you want. So that's 25 minus 9 equals X squared. So X squared equals 16. So X equals plus or minus the root of 16. So X equals plus or minus 4. But this side of the triangle is the triangle, so we can't have a negative length, so the side is 4. Now we can do the cot of B. Cot is the adjacent over the opposite. And so here's angle B. Cot is adjacent, which is 3, over the opposite, which is 4. And you just take your time and work these out. It's not that hard, but just follow the pattern. Again, triangle PQR, angle Q is 90. So we have a triangle. So here we have it. And it says Q is 90. So there's Q is 90. That means P and Q. You can put P here and R here, or you can put P here and R there. It makes no difference. And we have the cos of R. Well, let's make sure now. We're SOHCAHTOA. We write out S sine. SOHCAHTOA is O over H. C equals A over H. And tan is O over A. SOHCAHTOA. And again, if you think about it, that's a sine, S, so that's cosecant is hypotenuse over opposite. And we have secant, which is cos, is hypotenuse over adjacent. And we have cot, which is adjacent over opposite. So again, practice writing these down. So we have cos of is adjacent A over hypotenuse. So in the triangle, angle R, we have adjacent, which is 12, and we have 13 is the hypotenuse. Hypotenuse is opposite the right angle. Okay, and to make, now we want the secant of angle P. Secant is hypotenuse over adjacent. So here's angle P, is hypotenuse over adjacent. We have the opposite side of P, but we don't have adjacent. So again, we got to go C squared is A squared plus B squared. And again, if you want to call this side whatever you want, make it X. Then the hypotenuse is 13, so it's 13 squared, 12 squared plus X squared. So that's 169, 144 is X squared. 169 minus 144 is X squared. So X squared, when you subtract, you get a 25. And we do the square root of both sides. We can do the square root like that and the square root like that with a plus minus. So that's plus minus 5. Notice I just did the square root of X squared here, I call it X, and then I did the square root of 16 as plus minus. I didn't put the square root on both like I did here. And again, this other side can't be negative, so this X is a 5. So secant P is hypotenuse over adjacent, and the hypotenuse is 13 over the adjacent, which is 5. And hopefully you can see the pattern that I'm establishing here. Let's do another one just to make sure. C, we got a triangle X, Y, W, and angle X. So the right angle is at X. Now I can put Y and W anywhere, Y here and W here, or Y there and W there, makes no difference. And again, we want to make sure SOHCAHTOA, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. And cosecant, CSC, is hypotenuse over opposite. And secant is hypotenuse over adjacent. And cot is adjacent over opposite. So there it is. Remember, we got SOHCAHTOA, SOHCAHTOA. Very, very extremely important in trig. Okay, we have cosecant. Cosecant is hypotenuse over opposite. So I'll put that there. So that's root 2 over 1. Hypotenuse is opposite the right angle, so root 2. And here's angle Y, as opposite is a 1. So now we work out, we put X here, we go C squared is A squared plus B squared. Hypotenuse is root 2, so root 2 squared is 1 squared plus the X squared. Root 2 squared is 2. 1 squared is 1. Oh, there's a plus sign there. 2 minus 1 equals X squared. 1 equals X squared. So I'll do the square root of each side, but I have to do plus minus here. So X equals plus minus 1. And again, there's two values of X in this equation, but there's only one that fits the triangle. The triangle can't have a negative length, so we got to have the positive length. So we're doing tan of W. And W is here. And what is tan? Tan is opposite over adjacent. And in relation to W, opposite is 1 over the adjacent, which is 1. So tan W equals 1. Okay, hopefully you're seeing the pattern that I try to establish. If so, work out each of these. Do them before I do them to see if you know what you're doing. Hopefully you understand. Here we go. Triangle DEF with angle F is 90. So we have triangle DEF with angle F. I got to put my right angle in the right spot, but the two lines are perpendicular. So I have a D, E, and an F. So if that's the right angle, the D and E can go. You can switch these, your choice. And again, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. And the reciprocals is cosecant, hypotenuse over opposite, secant, hypotenuse over adjacent, and cot, C-O-T, is adjacent over opposite. And again, a SOHCAHTOA, S-O-H-C-A-H-T-O-A. I'm writing it down at the top of my page because all these questions are pertaining to this. So writing it down, you see it and you don't make a mistake. So here we go. We have secant. Secant is hypotenuse over adjacent. So let's 5 over 4 is hypotenuse over adjacent. So I didn't cram it in here. This time I wrote it down on the side. So therefore, hypotenuse is opposite the right angle, so that's a 5. In relation to angle E, this is angle E, so adjacent is this side, 4. So the opposite side, this is the opposite side to E, or its adjacent side to D. So let's call this X. And we have C squared is A squared plus B squared. C is the hypotenuse. I always plug the hypotenuse in first. And the other two sides are A and B. 25, 16, x squared. 25 minus 16 is x squared. X squared is 9. And we'll do the square root of 9 plus minus the square root of x squared. Square root of x squared is x. Plus minus the root of 9, which is 3. And again, this side of the triangle can't be negative. It has to be a positive 3. So the cosecant of angle D. Cosecant is hypotenuse over opposite. So I go hypotenuse is 5 over the opposite side is 4. Nope. Cosecant of D, again, just check hypotenuse over opposite. There's angle D, hypotenuse over opposite, 5 over 4. Perfect. Number 2, we have a triangle ABC. AC is perpendicular to BC. So let's draw a right triangle. AC is perpendicular to BC. AC, if we make AC is perpendicular to BC, C is repeated twice, so C is my right angle. So we lay A there and B there. AC is perpendicular to BC, C is repeated twice, C is the right angle. And we have all this information up here. We don't have to write it down again. So root 3 over 3 is the tan is adjacent. Tan is opposite O over A, opposite over adjacent. So in relation to angle B, the opposite is root 3, and the adjacent is 3 in terms of angle B. That means we have to go and find the hypotenuse. So we have C squared is A squared plus B squared. We're looking for X, which is the hypotenuse. And we have root 3 being squared, 3 being squared. Root 3 squared is root 3 times root 3 is 3. 3 times 3 is 9. X squared equals 12. And we'll do the square root of both sides, but we do plus minus. So x equals plus minus. And 12 is 4 times 3, so it's a 2 root 3. And we can't have a negative side, so it's a 2 root 3 for the hypotenuse. So secant A, secant is hypotenuse over adjacent. So in relation to angle A, hypotenuse is 2 root 3 over adjacent, which is root 3. And the root 3's cancel out, so I get a 2, or 2 over 1. Okay, let's do the last one. Again, I always draw my right triangle, and it says the angle P is 90. And P is 90, so I got Q and I got an R. Your choice, you can put Q here, R here, or Q here and R there, your choice. And we have a half. A half is in terms of sine. Sine is opposite over hypotenuse. So opposite over hypotenuse in terms of R. Opposite is 1, hypotenuse is 2 in terms of angle R. So we have to find the other side. So C squared is A squared plus B squared. And we have the hypotenuse is opposite the right angles, is 2. A is 1, and B is the x being squared. 4, 1, x squared. 4 minus 1 is x squared, so x squared is 3. Now I'll do plus minus the root of 3, and I'll do the square root of each side. That's plus minus root 3 equals x. And the length of this side is, can't be negative, is a root 3. And cot of Q, the cot of Q, cot is adjacent over opposite. In relation to angle Q, adjacent is 1. And the opposite is root 3. And to simplify that, I multiply by root 3 over root 3. And I do that to remove the radical from the bottom. Root 3 times root 3 is 3. 1 times root 3 is root 3. And we have the answer as the cot of, did I say that? I said the cot, yeah. I wrote the cot. I went to cot, but I wrote cos here. So that's cot, yes. Cos, cot is adjacent. Perfect. I thought I made an error then, but I wrote down like an S. And I thought I'm doing cot instead of cos. Anyway, hope you understand what we're doing here. I'm doing different types of videos because I'm not jumbling it all together and doing patterns, so you'll find them. And different videos have different layouts, different concepts and strategies. And if you like my video, click the like button, the subscribe button, notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content of my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.